All right, guys. Uh, this is the last lesson you're going to learn this year. It's factoring special products and specifically a difference of two perfect squares. And it's much easier than the special products that were perfect square trinomials. All right, so we're going to recall something from the unit that we were in when we got out of school in March. If I gave you a plus b times a minus b, notice that the first terms are both the same in each set, a and a. And the last terms are the same in each set, b and b. But the only difference is one is a sum and the other one is a difference. That has a plus, that has a minus. That's going to allow, these different signs are going to allow the middle term to cancel out when I use the distributive property. But I'm going to show you, we're going to go ahead and use the distributive property. I've set it up already, but I'm going to talk through it. So a times a minus b, what I did is this is the one I chose to break up, and this is the one I chose to keep. So I broke it up into a times a minus b, and then b times a minus b. Okay, right in here. All right, so I'm going to go ahead and use the distributive property. A times a is how I got a squared. A times negative b is negative ab, and I put my imaginary 1. B times A is BA, but I have to put them in order. We don't say A BA. Normally we just say AB, and I put my imaginary 1. And B times negative B is negative B squared. Okay. All right, so A plus B times A minus B produces A minus B squared. Okay. Now we say we have a difference of two squares. And we're talking about perfect squares when I say squares. And guys, a lot of times you'll just hear me say dots because sometimes I get tired of saying a difference of two squares. So I just use the first letter in each word. D in difference, O in of, T in two, and S. And squares, difference of two squares. So a squared minus b squared is a difference of two squares. Okay, so it is a difference of two perfect squares. If I say difference, it has to be a minus in the middle. All right, now, it can't alter between positive and negative in the middle. It has to be a minus in the middle if I say difference. All right, so let's look at this note. It says a difference of two squares always has first and last terms of the perfect squares, and a middle sign is always a minus. So can't help but have a minus because we have a difference. This difference is a binomial, okay? So whatever that difference is, it's just going to involve two terms. That's what binomial means. It says determine if the following binomials represent a difference of two squares. Okay, so let's take a look. I got to have a minus in the middle, first of all. So that's the first thing I'm checking is to see if I have a minus in the middle to represent distance. Okay, so is there a minus in the middle? Yep. Okay, apart from the minus, all you do is look at the first term. Okay, let me erase it. So you don't pay attention to the signs here. If you have a minus in the middle, ignore the signs. So you have 1 and 4x squared are perfect squares. Ignore the minus in the middle because all of them are going to be differences if they are a difference of two squares. Just make sure that they all have minuses. I'm going to write this better because I don't know what that is. Okay, can you move? Okay, it froze on me. Okay. One and 4x squared. Okay, so this would be a yes. Is there a minus in the middle? Sure. But if you look at y squared, is y squared a perfect square? Yeah, it is. But 14 is not a perfect square. So you put no. This is not a difference of two perfect squares. All right, I'll be honest on 3. 3, you got a GCF. And then you're supposed to check to see if it's a difference of two squares. But I really shouldn't have put this one on here, but I'm going to go ahead and leave it as it is. That's a minus. Is 100 x squared a perfect square? Yeah, 100 is, x squared is, and 25. Okay, both perfect squares. So this is a yes. Now we're going to factor number 3 in just a little bit, where you see that you're going to have an original GCF. All right, but let's just go ahead and look at number 4. Number 4, is there a minus in the middle to represent difference? Sure, there it is. Now I need to check, is p to the 8th a perfect square? Yes, because the exponent is even. And what about 49, q to the 6th? Well, 49 is a perfect square, and q to the 6th is, because as long as that variable has an even exponent, it's a perfect square. So that means the whole term, 49 q to the 6th, is a perfect square. Both perfect squares. So this would be a yes as well. All right, is there a minus in the middle? Yep, there is. All right, is 16x squared a perfect square? So let's check. All right. So I knew it was going to do that because it's like in slow motion. All right. $16 is a perfect square and x squared is a perfect square. That checks out. Okay, but 4y to the 5th is not a perfect square. Anybody know why not? Some of you saying, I know already. I knew it as soon as I looked at it. See this? 5 is, y to the 5th is not a perfect square, although that 4 is. Y to the 5th isn't, because in order for a variable part to be, the variable part to be a perfect square, you need to have an even exponent on it. That exponent is 5's so that makes it no. This is the problem, okay? That 5 is the problem, all right? All right. All right, let's check this one. Is it a difference of two perfect squares? So the first thing you're going to check is see if there's a what in the middle? Okay, there's a plus in the middle. So this is automatically a no. There is a plus sign in the middle. Okay, I think we got one more page and we're done because this stuff is so easy. All right, so the rules for factoring a difference of two squares. Okay, so I'm going to put something on here first that I failed to put on here. First, what do you think the first thing is? First, no matter what, if I didn't tell you to factor it using a GCF, you should always assume that you're going to look for a GCF first. That's what I want you to do. First, look for a GCF. Then follow the steps. So after you look for that original GCF, then you would follow the steps. So you would take the square root of the first term and the square root of the last term. Okay, we've done that with perfect square trinomials. After you take the square root of the first term and the last term, you write two binomial factors using the square roots from step A, just like we did with the perfect square trinomials. All right, but the only difference is the signs are going to be a tad bit different. It says make sure to write one factor as a sum and the other factor as a difference. With a perfect square trinomial, the way you chose your sign is you looked at the middle sign in the original trinomial. So if the middle sign was positive, then you would put plus in both of the factors. If your middle term was a minus sign, then you would put a minus in both of the factors. However, with these factors, you're going to put one plus sign in one of them, and then you're going to put a minus sign in the other one. That's so when you write the factors, if you decided to go back and check it and use the distributive property, you would not end up with a middle term, because a difference of two squares, they don't have a middle term. It's just a squared minus b squared. There's no middle. All right, let's take a look at it. Factor each difference of two squares, dots. All right, so I'm going to go here. First of all, I'm going to look for a GCF. So between 1 and 4, is there a GCF? No. Do they each have an X? No. So I'm going to put there is no GCF. Y'all see how slow it's writing? Okay. There is no GCF. So now what I can do is factor my difference of two squares. So you factor it the same way you factor the perfect square trinomial. You take the square root of the first and last term. So the square root of 1 is 1. The square root of 4x squared is 2x. But now, as far as the sign is a plus. Your signs on these, look at that. If I could just get it to write correctly, we could go ahead and finish this up. Your signs are plus and minus, okay? And we normally write it like this, plus and minus. All right, so we're going to write 1 plus 2x and 1 minus 2x. That's all you do. You're done. All right, you're going to take a look at 2. Is there a common factor? No. No GCF on 2. So I'm going to take the square root of p to the 8th. Basically, you just cut the 8 in half. Half of 8 is 4. So the square root of p to the 8 is p to the 4th. All right, then you have the square root of 49 y to the 6th power, which gives you 7 y to the 3rd. All right, and your signs bear with me. Are positive and negative. You're going to write one positive and one negative. So basically, you end up with p to the 4th plus 7y cubed and p to the 4th minus 7y cubed. Now, I could have put this factor first with the minus and then put this factor second, but it doesn't matter. As long as you have one plus and one minus, then you're good to go. All right, almost done, guys. All right, so is there a GCF between those two? No. So I'm going to put there is no GCF. So I'm going to go ahead and take the square root of 81. If you're watching this and you're being patient, thank you. The square root of 81x squared, which produces 9x. And then the square root of 25. See if I can write that better. Square root of 25 is 5. So you're going to write 1 plus and 1 minus sign for the sign. So you're going to write 9x plus 5 and 9x minus 5. And you're done. That's it. All right. there is no GCF on 4. I notice on this side it writes better. Now watch it mess up as soon as I say something. All right, the square root of x to the 14th is x to the 7th. And the square root of 144 is 12. And your sign is going to be plus or minus, or plus and minus. So you're going to write x to the 7th plus 12 and x to the 7th minus 12. Those are the two factors of x to the 14th minus 144. Now look at the last two. The last two, I'm just going to go ahead and tell you there's a GCF on the last two. All right, so if you look at 125, the GCF is 25. 25 is the biggest divisor of 125. 100 has x squared, but the 25 doesn't have an x at all. So I can't include an x in my GCF. So what do you always do with a GCF? You divide. So when we divide, we're going to get the remainder of 4x squared minus 1. But anytime you have an original GCF, what are you always supposed to do? Check to see if your remainder can be factored. Okay, here's my remainder. I don't want to write it underneath it. Why did it move it? I have no idea. Okay, undo. Can you please put it back? Okay, just erase. Erase it. Just get rid of all of it. If this thing keeps acting like this, I'm going to stop this video and open up another program to write in to finish all 5 and 6. Okay, guys? So we'll see how it goes. All right, so the GCF, the original GCF, was 25. Okay? All right, so when you divide, this is your remainder. You always want to check the remainder to see if it can be factored, okay? It can be factored because if you take the square root, it's a difference of 2 squares. This is dots, okay? So the square root of the first term would just be 2x, and the square root of 1 would just be 1, and you're going to put a plus and a minus sign in your factors. So you're going to end up with 2x plus 1 times 2x minus 1. But if you have an original GCF, don't forget to put it back out in the front. It leads, okay? So that is it in completely factored form. Check 6. They do have a common factor. The GCF, the original GCF is P. Okay, that's like P to the first, same thing. So I'm going to divide each one by P to the first. So that leaves me with P to the 4th minus 1. Okay. So this is your remainder. So you want to check to see if it can be factored. Okay, that's your remainder. It's also dots. It's a difference of 2 squares. So the square root of P to the 4th is P squared. And the square root of 1 is 1. Then you're going to make sure you have a plus and a minus in it. So you're going to write this as P squared plus 1 and P squared minus 1. Now some of you are going to catch this already. So I'm going to underline this. Anybody notice anything about this one? Let me do it in a different color. Anybody know anything about that one? There's something special about this P squared minus 1. So this is another factor, okay? All right, so look at that factor p squared minus 1. You can factor it actually because p squared is a perfect square. This is also dots, a difference of 2 squares. This one is. So I can just keep going with this. So the square root of p squared is p. And the square root of 1 is 1. Let me see if I can write this better over here. It's just so frustrating. Let's see if it gets better. Square root of p squared is p. Like I have to write super slow. And you're going to write a plus and a minus for that set. So I'm just going to look at the one I underlined. Okay, so the one I underlined is going to change into p plus 1 and p minus 1. Okay, now some of you are saying, well, what do I do about the one you didn't underline? So I didn't underline this one because it wasn't a difference of 2 perfect squares because I had a plus sign there. So I'm just going to bring it down. So I'm going to bring down this p squared plus 1. All right, so now somebody's saying, well, what about the original GCF, Miss Blue? Okay, well, there was an original GCF. The original GCF was what? P. What does your original GCF always sit? The original GCF always sits in the lead. So you put it right there. So all of this is the completely factored form of p to the 5th minus p. So again, I'm just going to make sure you understand that this sits right there. Okay? And that's that, guys. Just want to tell you all, I hope you enjoy your summer. I hope you learned a lot. If you ever need me for geometry or any other course that you're going into and I can help you, just email me or come by and see me, okay? All right. Love you guys.